Before we get started with the cut sheet, I wanted to go over another Windows secret. I need a shortcut to my video folder for this project so I can remember where it's at. So we're going to show you how to real quick create a shortcut to a folder. First, I need to browse to the folder. I'm going to press the key combination Windows key E to open up a File Explorer window. Now we're going to go ahead and browse. I already know where it's at. We're going to browse to my video PC room bookcase folder. We're going to open that folder. And now if we look at this window, right up here in the corner, there's a iconic representation of a folder. Grab that folder, drag it to wherever you want to create the shortcut, and you have a shortcut to that folder. And now let's get started on the cut sheets for my bookcase. Now that the design is completed, let's get started on creating a cut sheet for the plywood. First step in this is create another assembly. And here what we're going to do is we're going to add from my work group of all of the common stuff that I use for carpentry. I've got a 4x8 sheet of plywood. Now that I have my sheet of plywood, we're going to start adding all of the parts. Now I'm going to add all of the parts that are going to be part of the bookcase. Back to the workspace to place more parts and highlight all of the parts that are part of the bookcase. Selecting the shelf, side, top, and toe kick, tick the open button and then place them off to the side in the model space. Now I'm going to constrain all 4 parts to the face of the sheet. At this point of the process, it does not matter where they end up on the sheet. Moving the top and the toe kit off of the sheet because these are one-off pieces and not going to be part of an array. Now I sit back, visualize, and move things around to figure out what is the most efficient use of the space. For this project, I'm going to need 2 of the sides and an array of 4 of the shelves. Later, I will figure out where to fit the other 2 pieces. There's a good chance that the toe kick will be made out of solid pine and not part of the plywood sheet. With this orientation of the parts, there was a significant amount of the sheet left over, so I'm going to flip them around 90 degrees and see how that fits. Before creating the array patterns, I must first add the master worksheet with all the dimensions. In addition to the worksheet dimensions, I'm also going to need to know the length of the shelf. I can open the part model and copy the formula over to the assembly, but I've already stated that is not a proper procedure, so instead I am going to open the part model and then share that formula. I open the shelf and then pull up the parameters. The D0 parameter has the formula for the length. I go over to the export parameter column and tick that box and then add a comment. Close the parameters dialog box and then save the part before moving back to the assembly. Open the assembly parameters and then link to the shelf. In the link parameters dialog box, you can see the green arrow over the X and the D0 dimension that we just shared in the shelf. Click the gray circle with the line and we have just linked to the shelf. You can see in this share we would have had conflicting parameter names D0. Inventor fixes this for you by creating the shared dimension as D0_1. Optionally, you could choose to actually name those dimensions. Now it is time to create our array patterns, and first I will make a 2-part pattern for the sides. Selecting the part, then Pattern dialog box, selecting Rectangular Array, the direction of the array, leaving the default 2, and then putting the depth parameter plus the curve of the blade. There are 2 ways to enter the value for the curve, or anything else you want to enter in these dimension boxes. You can enter the actual dimension, in this case is 0.125, or you can put in the fraction 1 divided by 8. And now we have two parts right next to each other, and as you can see, separated by my 1/8 kerf width. First, I constrain the base component for the shelves to be patterned to the sheet. First, I constrain it to the side edge plus the kerf. Now, flush to the edge of the side. Now the base component is constrained and ready to be patterned in a 2x4 array. Now it is time to create the array or pattern for the shelves. First, select the part that will be patterned and then select the pattern tool. Select the direction of the column and, if necessary, flip the direction. Enter the number of components in this direction, in this case, the default 2. Now we enter the spacing of the components of the pattern. This will be the length of the shelf using the shared formula plus the kerf of the saw blade. Since this one will be a two-dimensional pattern, we select the row direction, number of parts in this direction, and the spacing will be the depth parameter that is part of the specifications plus the kerf of the saw blade. Now the two-dimensional 2x2 pattern is complete. But this has revealed that there is a problem where the shelves pattern is overhanging the sheet. To resolve this overhang, I will pull up the specifications and change the width of the bookshelf, but first I need to know how far it is overhanging. Pressing the M key on the keyboard brings up the Measure dialog box. Orient the model to see the edge of the sheet and the edge of the overhang, then select the two faces. Since there are two parts in the pattern, the value returned, 1.79, will be divided by 2 and then subtracted from the specification. Now back to the spreadsheet and change the length parameter to 26 minus 1.79 divided by 2. Save the spreadsheet, then back to the model, watching for the update icon to be activated, and then click it to see that now everything lines up. Opening the bookcase assembly, we get a pop-up informing that there have been modifications. Click the Yes button to perform the updates, then we can see that the length of the bookcase has changed to the new values. Reviewing this layout, I find that the amount of sheet used is well in excess of 1/2 sheet, meaning I would still have to buy a full sheet and I save nothing. Plus, the grain is going in the wrong direction in case I decide I don't want to paint it. I've decided I'm not going to paint it, which means the direction of the grain is important and I now need to turn these around. There are two ways to do this. I could delete the constraints of the base component in each pattern and then reconstrain in the other direction, or rebuild the arrays. After a quick review, which I'm not showing here, it turns out I will need to put the sides end to end. So, I'm going to delete the two arrays and start over. The process for creating the arrays do not change, but first I need to reconstrain the base components to the other orientation. After rotating and constraining the side to the upper left corner of the sheet, I create the new single-dimension array end to end for the two sides. Next, reposition the shelf next to the side and flush with the end of the sheet, then create the array for the shelves, also end to end. I could fit the top on what's left, or more likely I will cut it from a remnant I have lying around, leaving the remaining piece of this sheet for another project. Now it is time to run off to the lumber store and buy a sheet of plywood.